Feeling weighed down? Feeling the constant pull to the Earth? We all are. It's gravity, and it's a part of every single thing we do, including our science. But what if we're 250 miles above Earth, aboard the International Space Station, a laboratory like no other that offers something we can't get on our home planet?
My name is Dr. Serena Anand-Chancellor, NASA astronaut. I recently flew to the International Space Station aboard Expedition 56 and 57. My relationship with microgravity is that I got to live in microgravity for 197 days when I was on orbit. So many people ask, what is microgravity? Why do you float on board the International Space Station? Gravity acts upon all objects. We're never truly in zero gravity on board the space station. But because the space station is traveling so fast around the surface of the Earth, we're actually in a constant free fall. And that's why everything and everybody appears to float on board the space station.
We are experiencing the Earth's gravity. In fact, we're actually experiencing about 90% of what you all experience on the surface of the Earth. The difference is we're just moving so fast that as we fall, we actually fall around the Earth, and that defines orbit. So microgravity means we're not, it's not the absence of mass, which of course creates gravity, but all the objects together are in the same gravitational field and all falling together. So yes, it is a lot of fun. Floating around, of course, is one of the exciting parts of being up here on board and being an astronaut, but even more importantly, it lends itself to all the amazing experiments that we can do on board that take advantage of that microgravity environment to do things that we can't do on Earth, but that can benefit life back on Earth.
The important thing is it's so different than what we have here on the ground, where everything is pulled by the Earth at what we call one force of gravity. And what that does is it allows you to see the small forces, the small processes, the small effects of what goes on in life cell development or technical processes like combustion or fluid flow. And it helps you understand things that you may not have fully understood on Earth, where you see something happening, something assembling or disassembling, or the shape of something now going into 3 dimensions. And you learn, that's really what was driving this thing on Earth that we didn't really understand.
On Earth, gravity is affecting all research we do, and sometimes that can get in the way. Studying things in different environments can give a better picture of how they work, from diseases to fires and even things that make up products like milk or shampoo.
One of the main things we perform on the ISS is science. In fact, probably 70 to 80% of our day is performing scientific experiments.
The International Space Station is a great place to do research for several perspectives. One of those is it's a big, huge satellite orbiting the Earth. So if you have an instrument that wants to look at the Earth or look out at space, we provide the power, we provide the data, the platform for it. You don't have to go do your own new satellite. The outside of the ISS is also a very extreme environment, and sometimes you learn things by exposing your hardware, your polymers or whatever, to a different environment. You'll see something happen different than what is on the Earth. But probably one of the most pervasive uses of the ISS is just the microgravity environment, the things that we do inside the ISS. To be able to do your experiment in space without gravity, which we've all lived with forever here on the ground, which we live with every day, and we don't even realize how it governs so many things that happen around us. If you take gravity away, now some of the small phenomena, some of the small processes and forces start to come out, and you can see them, and you can see the behaviors of your experiment happening differently in space and in microgravity than you would on the ground.
It takes a lot of people to make all of that microgravity science happen. 4,000 scientists, companies, and students from over 100 countries have sent more than 2,700 experiments to the orbiting laboratory. Over the past 20 years, these studies have unlocked new discoveries and even kicked off hundreds of new microgravity experiments.
We're studying the physiology of how blood flow and our The fluids in our body shift as the result of microgravity.
Yesterday, I spent some time setting up a veggie experiment. We'll actually be growing Mizuna lettuce up here.
Drew and I actually have been helping start a new experiment called the Cold Atom Lab, which will create one of the coldest places in the universe right here on the space station, almost at absolute zero.
But who are these scientists? And how do they get their research to the space station? This season, we'll take you behind the scenes of the years of preparing an experiment for space. You'll see it launch off the planet and splash back down in the ocean, and hear what it's like to hand off your research to the astronauts who serve as the eyes and hands of the scientists aboard the International Space Station.
It's the launch day. It's a little windy out here today. It's a beautiful day. It's a little windy. It's got me concerned. My launch intuition is tingling a bit. I grew up here in Florida. I came to this very spot out here in the Causeway as a kid. My dad would take us to launches all the time. So personally, it's like the kid in me comes out when I come here. It's really cool. I've been on both sides of it. I've been a researcher, and then I've been now helping researchers. And I got to say, it's nervous on both sides. You have a lot of worry, I guess, as a scientist. You have a lot of work involved. As a payload provider, you hope you've checked all the boxes and you've done all that you can do to make everything work for the researchers so that they get good data. It's not easy to put even the most simplest payloads on the space station, but it's worth it. It's worth all the work. I think some of the biggest discoveries we've made and are going to find are up on the space station. It's incredibly important.
Well, we've been really nervous all the way up until right this moment. Nervous that our dreams aren't actually going to happen. But now that the larger countdown is happening and the rocket's all fueled up and everything looks like it's going to happen on time, it's getting really exciting. The last 15-minute window before it takes off. Thanks to Cases for funding this, thanks to NanoRacks for helping us coordinate and making the hardware and coordinating all the data collection too. And thank you for the astronauts who are going to be working on this project on station. So a lot of people worked on this. It's not just the two of us. It's been a lot of people. So we really appreciate all their support.
7, 6, 5, 4, 3, 2, 1, 0. And liftoff.
As Falcon 9 and Cargo Dragon take flight, bound for the International Space Station with fresh supplies and research, helping to maintain our human presence in space as this.
It'd be incredible just to watch it no matter what, but knowing that we have a personal investment in it makes a big difference.
Yeah, so it's just knowing that something that we've been working on is on it, and then watching the whole experience makes it just different. It really, I can't find the right words to explain it. Really,
definitely feel like the work leading up to it was worthwhile.
Yeah, absolutely. And watching it with your best friend.
Yeah.
And like someone that you've been working with for such a long time, and it's just, I think it couldn't get better. That's what I can say.
Yeah.
I didn't want to do it with anyone else.
Yeah, that is the exact same sentiment that I have too. So it was really special that we could both be here.
Yeah.
And watch it together.
Our scientist experiment is officially on its way to the International Space Station. The SpaceX Dragon capsule that gives the research its ride to low Earth orbit now must make the last leg of its journey to the hands of the astronauts in microgravity.
What's neat for us is we've got cargo vehicles coming and going to the ISS all the time. It is really like a busy parking lot. Vehicles come in, they stay for a few months, we do a whole bunch of science, and then they leave again. And before you know it, the next one's coming up. Now, what's important to remember is that these vehicles cannot dock themselves to the space station. We have to bring them into the space station utilizing robotics. And what I like to tell people is performing robotics, going out and capturing that vehicle is like a really difficult video game. And so we practice over and over and over again using computer simulations on how to actually capture that cargo vehicle to bring it into station. Once that cargo vehicle docks to station, we do a series of pressure checks and equalize that pressure with the International Space Station, and finally we get to open the hatch. Very quickly the crew starts to move because we've got some experiments that are actually kept at certain temperatures, and we have to transfer them quickly out and keep them at the same temperature there on board the space station.
Elaine and Peristu's research is one of the experiments that requires quick unloading. Stored at a constant temperature to ensure the hydrogels stay intact, it's one of the first items that astronauts must remove from Dragon. Then, with the experiment finally aboard the space station,
it looks like astronomers may have more fascinating discoveries to come.
And to make sure you don't miss out on anything mind-blowing happening in our universe by subscribing. Thanks for watching.